Hello, I'm David Brown at Berkeley Nucleonics, and this video series is going to walk you through all the features and functionalities of SpectraCore, our newly released software tool that matches up with the beautiful new RTSAs, the ICX400. Each feature will be defined in a small video so you can bounce around to just the features you need. Please reach out to us so we can answer any questions you have and get your hands on one of the new 40 gigahertz real-time spectrum analyzers on Berkeley Nucleonics. Today we are going to dig into the latest release of SpectraCore, our software for the ICX family of real-time spectrum analyzers. The latest design now reaches 40 gigahertz, capturing many of today's most demanding applications. Let's jump in. This video will cover 3 areas of the SpectraCore tool to enable you to jump right into productive work. We will cover the basic functions one by one, the user interface and nomenclature, and offer a couple measurement examples. First, let's introduce the default setup functions. We call this the SWP mode. When SpectraCore is opened, it defaults to SWP mode. SWP mode is the most basic and commonly used mode to run the spectrum analyzer. In this mode, the spectrum analyzer performs a spectrum panoramic scan. You can view the standard spectrum, spectrum local zoom, waterfall graph, and other chart contents in real time. SWP mode is also capable of performing measurements such as basic phase noise, IM3, channel power, adjacent channel power ratios, and occupied bandwidth. All spectrum data can be recorded and played back right from the SWP mode. Next, let's talk about the interface layout of SWP mode. The main settings area is divided into 4 submenus: Basic, Measurement, Data, and System. The Basic submenu is composed of frequency, amplitude, bandwidth, and trace data settings. The Measurement submenu includes the IM3, phase noise, channel power, adjacent channel power ratio, and an occupy bandwidth measurement. We can record and play back the spectrum data in a specified period of time from the data submenu. We can also set the reference clock source and system clock source in the system submenu and click the preset button to restore the initial settings. If you right-click the blank interface of the standard spectrum graph, a special function menu for the chart will appear. In the UI, this function menu from the chart region includes a Create Marker tool, Global Peak Search, Open or Clear, All Markers, Create Subgraphs, Export Data, and several other functions. The chart settings area contains 3 submenus as well: View, Trace, and Marker. This allows set of each of those elements. Honestly, if you start clicking, you will find it super friendly. I'm in my 50s and jumped right into measurements. Next, we will use a 2.4 gigahertz signal as the input to highlight some measurement examples in SWP mode. First, set the center frequency to 2.4 gigahertz and span at 300 megahertz. Set the reference level to minus 10 decibel milliwatts. Then set the BW setting to 50 kilohertz and use the default settings for your other parameters. Next, you can go ahead and adjust the amplitude display scale of the image. Click on the chart settings area and select the View submenu. You can adjust the amplitude display of the image by adjusting the scale, interval, and display offset. You can also quickly save the current trace as a memory trace by clicking the memory button. Now let's look at how to set up multiple traces and use some markers for each one. First, let's set up the trace to make it easier to observe. And we need to click the memory button again to cancel the previous memory trace. Then click the trace submenu in the chart settings area. You can click the drop-down box below to set the trace type as maximum hold, average hold, minimum hold, or several other trace modes. Next, right-click on the blank interface of the standard spectrum graph, and the chart additional menu will pop up. Select Create Marker Pair, and the marker pair of trace 1 is created. Here, after clicking on M1D marker, open the charts additional menu, and you can select Local Peak Search to find the local peak. After clicking the M1R marker, open the charts additional menu and select global peak search to find the global peak. Open the Chart Additional menu, and you can also select Marker to Center to move the signal to the center of the UI. You can choose to double-click on the trace location of interest to quickly perform the local peak search function on the current active marker. Open the Chart Additional menu and select Close All Markers to clear all existing markers. Then double-click on the trace location of interest, and the system will automatically generate a marker and perform local peak marking. The zoom graph and waterfall graph. Open the Chart Additional menu and select the first submenu under the Create Subgraph level. Choose Zoom Graph. After selecting the area to be zoomed, the system will create a local zoom of the spectrum. Open the Charts Additional menu and select the second submenu under the Create Subgraph level, Waterfall Graph. The system now creates a waterfall graph corresponding to the current spectrum. To make the graph easier to observe, we need to remove multiple traces that were added earlier. Open the Chart Settings area and find the Remove button under the Trace submenu. Then click the Remove button to remove each trace in turn, leaving only trace 1. You can close the Chart Settings area by clicking on the blank interface of the standard spectrum graph. You can perform handy measurements in the SWP mode, these including phase noise, IM3, channel power, adjacent channel power ratio, occupied bandwidth, and others. Here we will use channel power measurement as an example to demonstrate the operation. First, click the measurement submenu in the main settings area and select channel power from the drop-down box on the left. Then set the center frequency and measurement bandwidth of the channel power measurement and click the confirm button. Click the auto set button and the software will automatically configure the parameters for you. Next, click the basic submenu in the main settings area and change the frequency span to 300 megahertz. You can change the measured center frequency by selecting the channel box in the spectrum graph, holding down the left mouse button and dragging the channel box. Quickly adjust the measured frequency width by placing the mouse arrow in the channel box, rolling the mouse wheel, or clicking and dragging the sides of the channel box. After the adjustment is completed, the green number in the upper left corner of the channel box indicates the power of the channel at this time. You can also view the measurement results in the channel power section under the measurement submenu in the main settings area. Okay, now let me demonstrate how to record and playback spectrum data. You can click the Start Record button below the Data submenu to record the current spectrum data. You can also click the Open Record File button and select the file from your saved files. In this case, you will, to play back the spectrum data you just recorded, and you just click the Stop Record button here to terminate the playback operation. Finally, click the Preset button below the System submenu to restore the parameters to their default settings. Okay, thanks for following along. Let's move on to the next software tool in SpectraCore to get you most out of your HiCX FieldHawk, the 40 GHz spectrum analyzer.